Okay, so let's look at the Chapter 7 notes second handout. And this one is at the top of the page. It should say using and evaluating logarithms. And remember, we've learned that if you have an exponential form, like b to the c equals a, you can turn it into this other form right over here, logarithmic form, log base b of a equals c. And really, the reason that's useful is because you can plug stuff like this into your calculator and figure out what c is. So it's most useful when you start out with an equation like this and you need the c. Okay, so it's when you're solving for an exponent that you're going to need logs. So number one, first, let's just solve for x in each of these equations. We could use logs, but really, the way that these are written, you should be able to just kind of figure out, oh, well, x should be 3, because 2 cubed is 8. Right? 2 to the x is 1/4. Well, 1/4 is 1 over 2 squared. And so that's the same thing as 2 to the negative 2. And so x would have to be negative 2. But in this one, 2 to the x equals 15, there's no nice x that works for that. And that's where we use this change formula, this switching back in the conversion formula, let's say. So 2 to the x equals 15. That's like the b to the c equals a part. And then we need to convert that to log form. So this is supposed to turn into log base b of a equals c. So up here, this is going to be log base 2 of 15 equals x. So this is what I need to punch into my calculator. So let me start up this. And then we're going to go to alpha f2. Whoops, alpha f2 for log base. Now let me go back to the main screen. So number 5. And then the base is 2. And we're taking the log base 2 of 15. We hit enter, and it's about 3.907. You can kind of think about it. 2 to the 4th would be 16, so it should just be a little bit under 2, which is what it is. Okay, so logs help you solve for the exponents. And in fact, the log right here, that is the exponent. X is the exponent. So the log is actually a complicated way of writing an exponent. Okay. Then there's the calculator trick for how to actually write the log. And then let me rewrite that rule one more time down here. So let me make sure I get the letters right. Actually, here, I'll just do this. I'll just cut this and edit, copy, and we'll just paste it right down here so we can stare at it. Okay, so let me shrink it down a little bit. Okay, so there we go. This is the key rule that you're going to need over and over and over again in this unit. So in this one, all we're trying to do is convert logs into exponents and exponents into logs. Sorry, an alarm just went off. Okay, so log base 2 of y equals x. Well, 2's the b, so that turns into the base over here in exponential form. So that's going to turn into 2. And then the exponent is the c, which is the x in this case, equals y, if we use these conversions right here. And the next one, the base is 2, or sorry, the base is b. The exponent is 2, and that's supposed to equal x. And then in the third one, it's going to be 8 to the y equals x. The more you do of these, the quicker you should get. Really, if you have the log, it's this number to that number equals that number. Okay, going backwards, this one we've already been kind of doing. B is the 16, C is the y, and x is the a in this form. So this is going to turn into log base 16 of x equals y. This one's going to turn into log base z of y equals x. And this one's going to turn into log base 10 of y equals x. Now, one thing to note, log base 10, if it's a base 10, it's called, so let me write this, log with 10 here is called common log. The common log. It's got to have a 10, by the way. And you can write it as just log, no base. So if you write just log y, here, let me do this. Log base 10 of y is called the common log, and we can write it just as log y. Notice no number is here. That's kind of like when you write square root and you leave off the 2. It's implied that it's there. Same deal with log with no base. There is a button on your calculator for that. That's this one right here where it just says log. So if I did like log 5, that's the same thing as if I did log base 10 of 5. They're the same exact thing. So you can leave off the 10 if you want to. Okay, let's keep going. So evaluate each log without using a calculator. Let me cut and paste that thing again. Let me move it over. So I'll just put it right here. Okay. So the first one is log 100. And remember, that's the same thing as log base 10 of 100. What I'm going to do is when you can't use a calculator to do these, sometimes it's useful to actually set that equal to x and then rearrange it so it's in this form. So in that form, the base is 10, the b is 10, the c is x, and the a is 100. And then you look at this and see if you can figure out what it is. Well, 10 to the x is 100. That's 10 squared. So since the bases are the same, 10 and 10, then we know x has to be 2. Okay. Let's try it with this next one. If I set this thing equal to x, then I've got 2 to the x equals 32 when I rearrange that thing. The base to the x is going to be the inside of the log. Well, 32 is the same thing as 2 times 16, so there's going to be 2 to the 5th. So then that means x is going to be 5. Okay, let's set this one equal to x. So that's going to be 5, the little 5 here, the base, 5 to the x equals this 5. Well, that 5 is the same thing as 5 to the first, so x has to be 1. Okay, let's look at D. So in this one we've got, if I set that equal to x, then I know 6 to the x has to be 1. Well, 1 is the same thing as 6 to the 0. So then x is going to be 0. How about the next one? Log base 81 of 9. So if I set that equal to x, then I've got 81 to the x has to be 9. Well, I know 81 is 9 squared. And that equals 9 to the first. So let's rewrite this. That's 9 to the 2x equals 9 to the first. So the 2x has to equal the 1. So x has to be a half. And if you come back, maybe you would have seen this quicker. 81 to the 1/2 is the square root of 81, which is 9. So that's correct. Okay, let's keep going. Let's see, log base, so that's a base 10. Remember, it's implied, of 1 over 100. Let's set that equal to x. So then 10 to the x equals 1 over 100. 1 over 100 is 1 over 10 squared. And 1 over 10 squared is the same as 10 to the negative 2. So now we've got the same base, 10. And so the exponents are the same too. X equals negative 2. Okay, we'll keep going here. We'll call this one x. So 64 to the x equals 8. Well, 64 is the same as 8 squared. So it's 8 squared to the x equals 8. And then this becomes 8 to the 2 times x equals 8 to the first. So then 2x equals 1, and x equals a half. Okay, let's look at the next one. If I call that x, then we've got 2 to the x equals 1 over 64. 1 over 64 is 1 over 2 to the what? Let's see. 16 times 4, so that's going to be 6 2's down on the bottom, which is the same as 2 to the negative 6th. So then this means, since the bases are now both 2, the exponents are the same, x equals negative 6. Let's try this one. So if I call that x, I've got 1/5 all to the x equals 125. This one, maybe we're better off manipulating both sides. The side on the left is 5 to the negative 1 all to the x, because the inside is 1/5, that's 5 to the negative 1 on the inside. And then the other side is 5 cubed. And so then this side turns into 5 to the negative x equals 5 cubed. So then I've got negative x equals 3. So then I've got x equals negative 3. And there we go. And then j, let's see, we've got, if I call that x, 27 to the x equals 1/3. So this feels kind of like the previous problem. The 27 is really 3 cubed, and that's all to the x. And 1/3 is really 3 to the negative 1. And so then the left side turns into 3 to the 3x equals 3 to the negative 1. And so then the exponents have to be the same now that the bases are both 3. So x is going to be negative 1/3. So that's what the log is. And then this last one, let's see, log base 10 of 10 to the 6th equals x. So then 10 to the x has to equal 10 to the 6th. And so then I've got x equals 6. So this log equals 6. Okay. Let's see. We talked about the number e recently. E is really just some number that's about 2.71. And you can get it on your calculator by hitting second division. There's the E button right there, 2.718, right? It's actually more like 2.72. And hold on one second. Okay. And if we want to use the calculator to find a logarithm with base e, then we call it the natural logarithm. So if I write log base e of whatever, 20, right? This is an example, not number 4. That's the same thing as saying, oh, that's the natural logarithm of 20. And there's a special, it's such an important number that they give it its own symbol for natural logarithm. That's an ln. ln. I think it's for natural logarithm, but the n for some reason comes second of 20. So you can just write it like that. These two things mean the same thing. Same thing. So if we said, let's find the natural logarithm of 35, well, that's really log base e of 35, which is the same thing as, well, let's actually use the calculator and get it. So alpha f2 log base e of 35. So it's about 3.555. Well, we could have also done ln of 35. These mean the same thing. Well, and there's an ln button right here just next to the 4. So if we hit ln and then I type in 35, we get the same answer. All right, same answer right here. Okay. Find ln of e cubed without a calculator. So I'll write ln of e cubed. And then I like looking at it in the log form, log base e of e cubed. And then let's call that x, so we can figure out what x is. That's the same thing. So if we use the change formula, this one right here, paste, bring it over. If we use the change formula on this thing, e cubed is basically all inside that log. the e cubed is my a right here. The base is e. This is e, base. So I'm going to write e, because it's the b. And then to the answer, the exponent, equals the inside, e cubed, a. Well, that just means x has to be 3. Right there. So ln of e cubed is 3. Let's see, write 100 as a power of 2. So that means 100 has to equal 2 to the x. Well, in order to do that, we can just use this formula right away and rearrange stuff. So b to the c is 2 to the x. So I've got log base 2, and then that equaled 100. So log base 2 of 100 equals x. And then this you can't do by hand, so we're going to plug that into the calculator. Alpha f2, 5. Log base 2 of 100 equals 6.644, let's say. Let me make sure that was right. Yep, that's right. So then 100 can be written as 2 to the 6.644. So that's writing 100 as a power of 2. Let's do 14 to the x equals 5. Well, to solve that, we should rewrite it using that log formula. So that's going to be log base 14 of 5 equals x, and then we can plug this into a calculator. So alpha f2, number 5, log base 14 of 5 equals, and that's going to be 0.6099, let's say. So that's what x is. Write 50 as a power of e. So that's 50 equals e to the something. And we need the something. Well, if we use the log formula, that change formula, let's bring this down. Well, if we change stuff around, that's going to turn into log, because we're solving for the exponents, so this is where logs come in handy. Log base e of 50 equals x, using this change formula. Okay, well, log base e is the same thing as ln, so I can write ln of 50 equals x. Okay, well, ln of 50, let's just go back to the calculator. Ln of 50 is about 3.912. So then that means that 50 can be written as e to the 3.912. And that's how we write 50 as a power of e. Okay, and then we've got 2 more problems here, so we'll do these. Remember, we learned about compound interest. And if it's compounded a countable number of times, then you use this first formula. And if it's compounded non-stop, like there's no breaks in how often you compound, then it turns into this formula that involves e instead. Okay, so let's see, we've got 12, and p is the initial investment. So we've got $12,000 invested initially. And the rate is 10% per year, so I'm going to put 0.10 for the rate. Find out how long it takes for the investment to double if it's compounded semi-annually. Okay, well, then we want the total amount to be 24,000. And semi-annually means n is going to be 2. Okay, because n is how many times per year. So I'm going to set up what I can. 24,000 is the a, that's this part, equals p, which is 12,000, times 1 plus the rate divided by n to the n times t. And we're solving for t. So first let's get rid of the 12,000. So if we divide both sides by 12,000, we get 2 equals 1 plus 0.10 over 2 to the 2t. And then let's simplify the inside a little bit. So that's 1 plus 0.10 divided by 2. So 1.05. the 2t. And then let's change this around. So if we use that change formula, this is going to turn into log base 1.05 of 2 equals 2t. And then if we plug that left side in the calculator, log base 1.05 of 2, so that equals 14.2067. And then we just need t by itself, because we really solve for 2t. So if I divide that all by 2, we get 7.103 years. So there's that. That's how we do that one. Remember, I use the first formula because I can count how often I compound it. It's twice a year. In the second one, I compound it every single instant. So you can't count an n, and you can't plug an infinity, so when it's compounded continuously, we use that PERT formula. So in that one, A is still 24,000, because we're trying to double our investment. The original investment is still 12,000. The rate is still 0.10. And then that's all we have to fill in. So 24,000 is going to equal, this is the A, equals P e to the RT. So the P is 12,000. E is just some number E. And then R is 0.10 and T is just T. And we're solving for T. So again, let's divide by 12,000 first. So we get 2 equals E to the 0.10T. And then at this point, we can use that change formula. So it would be log base E of 2 equals 0.10T. And this side is the same thing as saying ln of 2 equals 0.10T. So now we can go to our calculator and type in ln of 2. So we've got 0.69315-ish equals 0.10T. And then if I divide both sides by 0.1, I get 6.931, let's just say that, equals T. So this is years. So if I compound every single instant, then I get to double my investment a little bit faster than if I just compounded twice a year. And the more often you compound, the better off you are. Okay, hope that helps a little bit.